At the creation of a plain old variable, you only have one consideration to take. Should I make it constant or should I not make it constant? However, when you make a pointer, there are two different considerations to make. First of all, whatever this pointer that I'm creating, whatever it will be pointing to, do I want this thing that it's pointing to be changeable through this pointer, or do I want it to be constant through this pointer? If I want to enable this pointer to have the power to change what it's pointing to, I will have to make it a plain old pointer that's not constant, like this one over here, pointer 1. However, if I only want this pointer to do nothing more than point to a variable, I don't want to give it the possibility of changing that variable, then I will make the type that it's pointing to constant. I'm creating a pointer which points to a constant, whatever the type is. So, and as I explained, that it's even possible that whatever it's pointing to really is not constant, but from the perspective of this pointer, it looks at it as if it's constant and it will never be able to change it. That's one consideration. The other consideration is, do I need this pointer to point to one and only thing throughout its whole lifetime? Or will I be using this pointer to point to one variable and then later on change it to point to a different variable, etc., etc.? So with these two considerations, we have our four possibilities of making pointers. A plain old pointer which points to a changeable variable, and it is a changeable pointer. Then we have a pointer which points to a unchangeable variable, but the pointer itself is still changeable. Then we move on to our pointer 3 and pointer 4 over here. Pointer 3 is a pointer which will point to a changeable variable, but the pointer itself is unchangeable, and pointer 4 will point to a unchangeable variable, and it will always point to one and only variable forever, for its whole lifetime. So now that you know a little bit about the constant keyword and how it keeps variables under control, let's see how this can help us with the issue I was talking about in a recent video when we got into this about the constant keyword. I was talking about how we could figure out solutions for several of the problems that we have when we use heap memory when we create our variables with the new and delete keyword. That problem being that whoever and wherever has a pointer to the variable that's created on the heap will have absolute full access to play around with that variable, and we don't always want to have that because otherwise it behaves pretty much like a global variable, very much against the rules of object-oriented programming. Let's say I create a class called bank right over here, and somewhere along the way this bank class has a variable, whatever type it may be, but it's some sort of delicate information which we want to protect so that only the objects of the class bank will have control over this delicate information, but other objects and the rest of the program should not have access to change around this stuff. And yet they should have access to see the stuff and read it through the public interface of the class. So you would probably make a public interface, a public function, which will provide us with the possibility to access this information. Now, if it was just one single integer, then we would probably make this function return one integer and that's it. But many times it won't be just one simple integer. It may be an instance of a certain class that you yourself created that could be very, very big, that has a lot of variables inside of it. So you wouldn't want to make this function return the whole entire data set type over here with this function for reasons that we'll get into more details a little bit later in another video. Also because you want to provide access to the actual object of this class. However, if you just return the delicate information object as it is, as we learned, this will only make a local copy to the calling function. So forget about all the details for now. What I'm getting at is many times, or most of the time, you're not going to want to return a actual object from this function. You're going to want to return a pointer to the object in this public interface. So in our example over here, when you make a function that will get the information, you're not just going to return the integer itself, you're going to return the address of this delicate information as a pointer to the calling function. The implementation of this sort of function may look something like this, returning the address of the delicate information, which will be returned as a pointer to whoever called this function. So whoever called this function will now have a pointer to this variable right over here, and so we successfully got our information. Now over here right away we see the problem. When I'm returning the address of one of my private variables over here to a calling function, that calling function will now have the access to this variable, and it will be able to change it around and do stuff to it that I don't want it to do. That's what pointers are all about. They don't have the rules of scope that one world cannot affect another world. With pointers, one scope can affect another scope. So when you're dishing out pointers to your private stuff in your class, whoever has that pointer will now have full access to change around those stuff in the class. We don't want to have that. We want to protect our information in our class. It's private. It's nothing that the rest of the world should be able to access so easily. And so what you would want to do is make this function return a pointer to a constant integer. Right now we are forcing whoever is calling this function to, yes, have access to the variable, but not ever have the power to change this variable that it's pointing to. Another example would be if I'm creating a variable over here on the heap memory, to which I now have a pointer to it, because I'm trying to stay object oriented, and I know that this pointer makes sense to belong in the main function for whatever reason, and it doesn't make sense to be part of another function somewhere else. It makes most sense to belong over here in the main function. Then I would probably also want to protect it that even though I will pass this pointer into a different function for whatever reason, that other function will not be able to change my pointer and the variable that it's pointing to. So let's say, for example, at some point I'm calling this other function do stuff, and I'm passing in the pointer to this new variable that I created on the heap memory. So I feel a little bit at risk over here. I am somewhat exposing this pointer for another function. Maybe this other function is going to delete the pointer. Maybe it's going to assign the pointer to something else. And by the time this function that I called, by the time it returns, maybe this pointer will be totally changed. So if you want to protect your pointer and the variable that it's pointing to, you will make this other function do stuff, not take a regular pointer that can change around, but rather you will make it a pointer which can't change the value that it's pointing to. And you might also want to make the pointer itself constant so that you don't assign a pointer to something else. This way we protect our pointer from the main function, so that when we pass the pointer to other functions which can read the pointer, they will not be able to write to the pointer and change it around. So here's a little piece of advice. Try to use the constant keyword as much as possible. You should have the constant keyword hanging around your code as often and as common as creating variables or typing numbers. As soon as you create a variable anywhere or a pointer, make it all constant from the beginning. Then, as soon as you hit a wall where you see that you can't have this constant because it just doesn't make sense, we need to change it and we need to do this and that, like over here, we can't possibly make this character f, we can't make it constant because the whole point of this character f is that in another second right over here, it's going to get its value changed with the user input, with this CIN magic. If it was possible to somehow assign the user's input to the character f in the very same line the character is created, I would make it constant right away. Like if it was somehow possible to make the CIN magic be on the very same line of creating the character F. But unfortunately this isn't possible, so we have no choice. But most of the time try to make everything as constant as possible.